friends, welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about linear search program. In today's video, we will learn about the second type of searching technique, which is binary search. How to do this binary search? Is it linear search or the binary search which is best? All these things we are going to learn by understanding the tracing of binary search and its algorithm. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So what is this binary search? So we have actually two methods for searching. One is linear search, the other one is binary search. The best method used for searching is binary search. Why this is the best method? Let us understand. We have seen linear search. The linear search, what we do? We do the searching in a linear fashion. We start searching the element from the first element and we go on traversing. And when we find the search element, we grab that position and the searching will be stopped. But if the element does not exist in the array, it has to start searching from the beginning till the end. So when I reach to the end, then I'll get to know that the element does not exist. But I have to traverse the complete array. So it consumes more time. If the element is available, maybe say you have 10 elements and the element is in the last position, I have to traverse up to the last position one by one in a linear fashion itself. I cannot straight away take a jump to that position. Or it may be available in between, maybe towards the left side initially or maybe towards the right side at the end. So it may be available in between. I have to traverse from the beginning till that position. When I reach that position, when the search element is compared, I have to grab that position. Then I need to stop the iteration, stop the traversal. But I need to do the traversal one by one after the other in a linear fashion. That is in linear search. So it is consuming more time, more comparisons. But in binary search, this is not the case. We can search the position of the element very quickly. How is it possible? The name itself tells you by. By means 2. So, the complete array is divided into 2 parts. The complete array is divided into 2 parts, and after dividing, what we do? We are going to compare the search element with the mid element. So, for example, if I divide this complete array, so here what happens? I have this division. Right. So, how to get the mid element, how to divide the array? There are some formulas that what we need to follow. Okay, just imagine I have divided this array. Binary search says you do the searching by dividing the array into 2 parts. By says 2. You divide the array into 2 parts. How to divide the array into 2 parts? We'll see. After you divide the array into 2 parts, I have to compare the search element with the element in the mid position. If the element is compared with the mid element, my work is done. I'll simply grab the position and I'll come out of the loop. But if not, I have to go towards left side or right side. I have to move towards left portion of the array or right portion of the array. So how I can do that? So I need to compare the search element with the mid element. If the search element is found to be less than the mid element, I go towards left portion. If the search element is found to be greater than the mid element, then I go towards right. How is this possible? This is possible only if the elements are arranged in a sorted order. So there is one criteria for binary search. It says If at all, if you want to apply binary search method to search for the elements must be arranged in ascending order. Means it should be sorted. So one thing, we divide the array into two parts. For that, the first criteria for binary search, it says the elements must be sorted. I need to give a sorted array. See, in the sorted array, we all know the elements will be arranged from lesser to larger. So all the lesser elements will be towards left. All the lesser elements will be towards left. And all the greater elements will be towards right. Lesser will be towards left and greater will be towards right. So when I compare the search element with the mid element, if the search element is compared with the mid element, I'll simply grab the position. If not, I need to do one more thing. If the search element is lesser than the mid element, if it is found to be lesser than the mid element, then I have to move towards left. But if the search element is found to be greater than the mid element, I have to move towards right. So for example, my search element is 20. So I'll divide the array into two parts. How to divide? We'll see that later. After dividing, I have to compare the search element 20 with the mid element. So is 20 equal to 30? No. Okay. Then I need to check, is that search element 20 is less than the element in the mid position. Is 20 less than 30? Yes. The search element is less than the element in the mid position. Then I have to move towards left. When I move towards left, what happens? Here we call this as lower bound, which is 0, and 4, which is upper bound, means n minus 1. So n minus 1 is upper bound and 0 is lower bound. So when I say when the search element is less than the mid element, I have to move towards left. Means the same, my elements are available towards left. So when I move towards left, this lower bound remains the same. This upper bound I need to change. So I need to divide the array. What I said, I have to search only to the half portion of the array. The remaining portion I need not touch. I have to move only towards left portion. If the search element is found to be less than the element in the mid position, if the search element is less than the element in the mid position, I have to move towards left. When I move towards left, the lower bound remains the same. Only the upper bound I need to change, where I need to say upper bound equal to mid position minus 1. So mid position 2 minus 1. Till here. My array is only this much now. That's it. Just imagine you have very large elements, 10 to 20. So when I divide the 20, you will get 10 elements towards left and 10 elements towards right. Again, when I come to the 10 elements, my lower bound will be 0. Upper bound I need to change. From 19 to, I have to bring back. But if the element is found to be greater, say I want to search 40. Now compare 40 with the mid element. Is 40 less than 30? No, it is greater. Means the same, my elements are towards right. So when I move towards right, upper bound remains the same. Lower bound has to be changed. So I just say lower bound equal to mid plus 1. So lower bound mid means it is 2 plus 1, it points here. So my array will be only this much. Got it? So if it is less, I move towards left, lower bound remains same. I need to change the upper bound. I need to bring this upper bound to point here. If it is greater, upper bound remains the same. I need to bring this lower bound to this position. That is lower bound equal to mid plus 1. So how to do all these things, we have to understand with algorithm. This is the process of binary search. So in the binary search, the name itself tells you I do the searching by dividing the array into two parts. How to divide? We have a formula for that. right? After dividing, we compare the search element with mid element. If it is get compared, I simply get the position. My work is done. It's finished. If not, I need to check whether the element is less than the element in the mid position. If it is less, move towards left, because lesser elements are towards left. When I'm moving towards left, the lower bound remains the same. Upper bound, I have to bring it here. So I just say upper bound equal to mid position minus 1. But if it is greater, if the search element is greater than the mid element, then what I should do? I have to move towards right, where upper bound remains the same. Lower bound, I have to bring it here. So I need to search any one portion of the array based on the condition. Either the left portion of the array or the right portion of the array. So how I can go to the left portion of the array, right portion of the array? We have to understand that with algorithm. So what this binary search says, so when the elements of the array in sorted order, then only I can apply this binary search technique. So binary search works only if the elements are in sorted order. So in this method, what we do, we compare the element. This method compares the element to be searched with the middle element of the array. If the comparison does not match, the element is searched either at the right half of the array or to the left half of the array. If it gets compared, well and good. If not, I have to go to the right portion of the array or left portion of the array based on the condition. So, when I divide the array into two parts, I need not traverse the complete array. I need to traverse only half portion of the array. It is like divide and conquer rule. When I come to left side or right side, once again I do the process of dividing the array. I divide the array, then once again I set the upper bound, lower bound like this. This is what the binary search technique. So how to divide the array, how to find the mid position, all these things let us understand with the algorithm. So hope you have understood the simple technique of binary search. Very simple. Divide the array into two parts and then compare the search element with mid element. If compared, good, get the position. If not, go to the left portion or right portion based on the condition. If the element is found to be less, move towards left. If the element is found to be greater, move towards right. I can just give you a clue to just remember this. A less means left. If the search element is found to be less than the mid element, less, move towards left, LL. So when I move towards left, just imagine virtually left means the lower bound will be the same. That's just imagination. Lower bound will be the same. I have to bring the upper bound. So I need to subtract. So it is upper bound equal to mid minus 1. If not, means greater. Greater, R, move towards right. Move towards right. When you move towards right, what happens? The ending position will be the same. Upper bound will be the same. Lower bound I need to change. Means it is lower bound equal to mid plus 1. So all these are the formulas and criteria that what we need to follow. Let us apply this in the algorithm and still understand in a better way. So here we go with the complete algorithm of binary search. So remember all the points that what we discussed previously. That is about the actual criteria for binary search, saying that the elements must be in sorted order. So imagine we have these elements as sorted elements 10, 20, 30, 40 and 50, and the size of the n is 5, and the element that what I need to search is, let me take the search element as 40. The search element is 40. So I need to find the position of this element 40 with binary search method. So what I need to do, I need to set the bounds, lower bound and upper bound. So let me treat this as lower bound and upper bound as beginning and ending. So lower bound, which is, I can treat that as B, which is 0, beginning index, 0. Upper bound, which is ending, which is n minus 1. N is 5, 5 minus 1, it is 4. So this is what the upper bound treated as end. Beginning index, ending index. Beginning index is 0, ending index is n minus 1. Fine. Now, and also we need to set the location to minus 1 by default. So these are some initializations that what we need to do before we start the searching process. So it is beginning, which is 0. So beginning is 0, ending is n minus 1 means 4, and location is minus 1. So when I start the binary search process or any searching process in the array, the first thing that what I should do is I should always check the bound, that whether I am within the array bound or not. If I am within the array bound, then only I can do all this traversal or any other process. So I need to start a loop which says to check whether we are in the array bound or not. So let me write the iterations. So here let me start writing the iteration. So I need to check whether I am within the bound of the array. So I just check as beginning, that is 0, less than or equal to ending, that is 4. Beginning and ending. Is 0 less than or equal to 4? Yes. 0 is less than 4. Means to say I am within the bound of the array. When I go out of the bound, means to say I can't search any elements. There is no more elements if I go out of the array bound. So I need to be within the bound of the array. So I need to have this while loop. Inside the while loop, we'll do all the comparisons, we'll divide the array, all those things. So what is the formula to divide the array? It is beginning plus ending divided by 2, which will give you the mid position. Position, not the element, mid position. So I need to check the bound. If it is true, then I'll get inside and I need to find the mid position. So I say mid equal to beginning plus ending, 0 plus 4 divided by 2, and the mid position, and you all know the index should be always in the integer type. So index values cannot be floating type, it should be integer type. So I said beginning plus ending divided by 2. So this mid position should be of integer type. It should be of integer type. So 0 plus 4 divided by 2, it is 0 plus 4 divided by 2, which is 4 divided by 2, the answer is 2. So the mid position here, it is 2. So let me write the mid position. So let me write all this beginning, ending and mid position. 0 is beginning, 4 is ending. What is the mid position? It is 2. Mid is 2. Now I have divided the array into 2 parts. The array is divided into 2 parts now. The array is divided. So now I have to go towards left portion of the array or right portion of the array. Left portion or right portion. So now what happens here? When I go to the mid element, I need to do the comparison with the search element. So this part is done. Check the array bound, then find the mid position, then I need to compare the search element with the element in the mid position. What is the search element? Search element is 40. Is 40 equal to A of M? M means 2. What is A of 2? That is the mid element, which is 30. Is 40 equal to 30? No. My search element is not compared with the mid element. Condition not satisfied. If condition satisfied, I'll simply grab the position and my work is done. If not, what I should do? I need to compare this search element with the mid element in such a way that I need to check. See, if this condition not satisfied, come to else part. Come to else part. So in the else part, what I need to do? I need to compare the search element is less than the mid element. So what is search element? I'll come to else part. Search element is how much? It is 40. Is 40 less than A of M? M means 2. That is A of 2 means 30. Is 40 less than 30? Is 40 less than 30? No. Condition not satisfied means it is greater. If 40 is not less than 30 means it is greater. So when the search element is found to be greater than the element in the mid position, what should I do? I have to go to the right portion of the array. When I go to the right portion of the array, ending remains the same. The beginning I have to bring it here. So what I will do? Search element 40 less than 30, condition not satisfied, immediate statement will not be executed. Come to else part. I need to change the beginning. Ending remains the same. Ending will be 4 only. Beginning I need to change. I say beginning equal to mid plus 1. What is mid? It is 2. 2 plus 1 which is 3. So what is beginning? See, I am bringing this beginning pointer. So when I say I want to move towards the right portion of the array, ending remains the same. Beginning I need to change. Beginning I say mid plus 1. So now I'll change the beginning. Beginning is 3. This is what the beginning. This is not the beginning. The beginning index is 3. So my array is only this much now. Only this much. I have only 2 elements. So I need to do the searching between these 2 elements. See how simple it became. I divided the array into 2 parts. Then I'll decide whether to go to the left portion or right portion based on some condition. So if the element is found to be less, I'll go towards left. If not means greater, I have to move towards right. When I'm moving towards right, ending remains the same. Beginning I need to change. So beginning equal to mid plus 1. See. Greater means R. Just imagine greater R. Move towards right. Greater means highest plus. Ending remains the same. Ending remains the same. Mid I need to change. Mid plus 1. Beginning I need to change. Beginning equal to mid plus 1. Beginning I have to bring it here. So it is mid plus 1. So beginning changes. Now beginning became 3. So after this I have to loop back. I need to check the condition once again. See now the beginning and ending values has been changed. Ending remains the same. Ending is 4 only. Beginning is changed. 3 and 4. Now check. Loop back and 3 and 4. My array bounds 3 and 4. I need to check whether I am within the array bound or not. Only the right portion of the array where we have only 2 elements. Check. Is 3 less than or equal to 4? My next iteration. So this is what the next iteration. Right. 3 less than or equal to 4? Yes. Condition true. I am within the array bound. Condition true. Once again get inside, find the mid position. See when I go to the one portion of the array, once again I need to divide that portion also. Just imagine you have 5 elements towards left, 5 elements towards right. So when you go towards right, once again you get one portion of the array. Again you divide that. This is what the technique here. So here I need to find the mid position. I say mid equal to, this is what beginning, this is what ending. So it is 3 plus 4 divided by 2. It is 7 divided by 2. As I said, mid is of integer type. So it is 3.5. It will take only 3. 3 plus 4 it is 7. 7 divided by 2 means 3.5. As mid is of integer type, it will take only the whole part. So it is 3. So the mid position is, it is 3. Mid is also 3. Beginning is also 3. Mid is also 3. My array is only this much. Very small array where I have only 2 elements. When I divide that, beginning also remains the same, there only mid also remains the same. So mid is 3. Then what I'll do, I need to compare the search element with that mid element. What is the search element? It is 40. Is 40 equals to array of m. What is m? It is 3. What is a of 3? It is 40. Is 40 equal to 40? Yes. Condition true. Then what I should do? I have to execute these two things. I'll simply grab the position, location equal to m. So the new value that what I am getting is the value of m. What is the value of m? It is 3. Now location is changed. So location was -1. Now it is changed to the mid value, which is 3. So I got the position. The search element 40 is in the position 3, right? Yes. Search element is found to be compared with the mid element. Simply grab the position, then go to step 3. Step 3 says, if location is greater than or equal to 0, what is location? What is location? Location value I have got it as 3. Is 3 greater than or equal to 0? Yes. Condition true, print the location. Means 3. If not, the search element does not exist, then this condition goes out. I will be out of the array bound. Then I'll come to else part. It will be -1 only. -1 greater than or equal to 0? No. Come to else, print search unsuccessful. So hope you have understood with this tracing. So here is an assignment for you to check with the search element, say 60. Is 60 available here? No. So what should I get? Search unsuccessful. How it will search that 60? How it will go to left part, right part? You have to do the tracing like this. So this is what the tracing of the binary search. Let us understand the program of this in the next video. So hope you have understood with the tracing of binary search with this algorithm. So that's all for today's video. Assignment you have to do, and you have to write down the tracing in the comment box so that I'll get to know that you have understood the tracing of this binary search. Any doubts, you can put it in the comment box. Well, that's all for today's video. See you in the next video. Till then, take care. Bye-bye.